Hey everybody, just want to make a real quick video for a heads up for the lab you're going to be doing for automatic input devices. You're going to be working on the Amatrol trainer, and I've posted some pre-lab reading material. If you'll read that material, it'll save you a lot of time in lab, and it'll keep from log jamming the trainers and keep your time down to a minimum in the lab. Okay, so if you go ahead and read that, that's why I put it up there. That way you come in there, hit the skills, and you're ready to go. The other part of the lab is going to be a hands-on wiring that a lot of you have told me that you really like and you get a lot out of. So I've got an exercise where you're going to be doing that, okay, and that's what this heads up's about. I kind of want to go over it because it sort of interfaces 24 volts with 120, and it also utilizes a completely different type of control relay. When I say it's completely different, the only thing different really is that it looks different. The operating fundamentals behind it, the principles, they're all the same, okay? So I want to make this video real short, but so we're going to go ahead and jump right into it, okay? Here is our schematic. We have got 208 volts feeding a primary of a transformer that we're going to 120 volts out, okay? Now, we're going to take that 120 volts, and on the first rung of our logic, we're going to feed it to an Allen Bradley power supply. That power supply is going to take 120 volts. It's going to step it down to 24 volts AC. Then it's going to rectify it to DC, okay? And as soon as we put the power to 208 volts, we're going to get 120 and also get 24 volts DC right off the bat. There are no switches, okay? So we're going to wire it directly to our power supply, so there's no switches to turn on to get the power supply to come on. It's just going to boom. As soon as we hit the 208 to the primary, we're going to get 24 volts in addition to our 120. We're going to take that 24 volts, the 24 plus and the 24 minus, and we are going to feed it over here to this small circuit over here. Now this dotted box around here tells us that this circuit here and this circuit here are integrated together, okay? These are the contacts in this box right here, this dotted box. These contacts actually belong to this control relay over here. So we're going to take the 24 volts right here and we're going to feed this proximity switch. When we make up the proximity switch with a piece of ferrous or non-ferrous metal, the target, whatever, when we make that up, we're going to energize a 24 volt coil on this control relay, okay? That will in turn close a set of normally open set of contacts. We've just got them wired in this 120 volt circuit, okay? But the principle is still the same. We energize this control relay coil after we make the proc switch up. Voltage 24 volts passes to the coil, and it makes and breaks a set of contacts. What we put on those contacts is totally up to us. We'll make and break those set of contacts, and in this case, we're going to make and break 120 volts across those contacts, okay? So we've integrated the set of contacts right here that are on board this 24 volt control relay, and we've stuck them in the 120 volts. Now the voltages are never crossing over or meeting or anything like that. They're completely independent, completely isolated. So we've stuck this set of contacts in here with 120 volts sitting there waiting on it. As soon as this 24 volt coil closes or energizes, it's going to close and pass that 120 volts to the motor starter. So the motor starter is going to come on. So again, we're going to push the push button right here, and nothing's really going to happen until we make that proc switch up. So we make the proc switch up, energize the coil, these contacts close, okay? They're going to stay closed. As soon as we hit the push button, we're going to provide the voltage there to these contacts. It'll be passing it through to the motor starter. The 120 volts on the auxiliary contacts for the motor starter are going to keep it sealed in, and the motor will run provided we always have a target right there next to our proximity switch. The moment we take that piece of ferrous or non-ferrous metal away from our inductive proximity switch, the coil de-energizes. When the coil de-energizes, this set of contacts opens, and that's what will break the 120 volts going to the motor starter. So you can kind of see how these two are integrated. It's not uncommon to have multiple volt or more than one voltage between two circuits. You'll see this sometimes. Now, the control relay right here, CR1, okay? That control relay is an ice cube relay. It gets its name because it looks like a small ice cube. All right, it plugs into a modular base, and you wire the modular base. All right, but again, it still has a coil that energizes and pulls an armature down. and it's still got contacts that open and close accordingly. These look a little different than the ones that you're used to seeing on the Allen Bradley or Siemens control relays, which is why I put them in here, because there are a lot of these still used. Even with PLC systems, there's still a lot of these used. So we're going to energize, this will be where our proximity switch is wired to. So we put the 24 volts here, we pass it through our coil back to the negative side of a power supply, and it energizes this coil. Our 120 volts is going to come in here on terminal number 9. Now you'll notice right here there's a continuity between terminal number 9 and number 1. That's the normally closed set of contacts. As soon as we energize the coil, this vertical bar right here will shift off of this set of contacts and onto this, so then we have a path between 5 and 9, and the path between 9 and 1 is now disrupted because that's a normally closed set that opens when we energize the coil. So our 120 volts is going to come into here. We're going to energize the coil. It's going to exit out on terminal number 5. Terminal number 5 will then go straight to the motor starter and energize it, okay? So you got 2 coils going on at one time. This is a completely independent set of contacts from over here. They do the exact same thing. We only need 1 set of contacts. If you'll notice, just 1 set right here off of CR1 is being used, okay? But we have another set available if we were to use it for something else. I'm not worried about that right now, just focusing on this. But again, just a little heads up, wanted to try to get your head around this ice cube. Like I said, it's different looking, but that's all that's different about it. It just looks different. It still operates on the same principle, and I hope this has helped. So anyway, this is the little preview for the lab. Be sure to get in here, and if you have any issues or problems or anything like that, by all means come see me, find me, we'll work things out. But other than that, that's it. Hope this has helped, and I guess we'll see you in the lab. Thanks a lot.